stops different processors from stepping on each other as they're going after the resources. You don't want 4 processors all to put the same lock on the same page at the same time. The latch says, gimme, it's mine. And if you can't get the latch, then you wait for the latch. By the way, if you see things like spin locks are very fast locks which go after latches specifically. The difference between a spin lock and a regular lock is that if you have a regular lock and you're waiting for a page, you get aged out. You go back into the wait queue, and the processor does something else. But the spin lock says, can I have it now, 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 like a kid in the back of the car on a medium-long trip. By the way, don't get involved with a Sybase bug where spin locks are getting out of control. This happened to us, about 7-8 months ago, and we ended up making 16 processors spin at 100% because we found a bug which was fixed, which caused all the spin locks to run. That was interesting to track down. So things like latch waits, if you see a lot of latch waits, there are some things that you may identify. There may be a lot of DBCCs, update stats. If you're not running this overnight, chances are, though, that when you see latch waits, you find that you're missing an index. So lots of different types of things that you might see. You do need to do a little bit of correlation and understand what these things are. But as database geeks, we like doing this sort of stuff. So spending time figuring out what these are can be time-consuming. It's nice to have graphs to pick these things up. It's nice to have a tool to pick these types of things up. You tend to get used to the types of weights types that occur at your shop because applications tend to be I/O intensive or CPU intensive or network intensive or fill in the blank. If you have a very mixed use system, well, just that much more fun. So Sybase gives us MDA tables. That came out in 12.502. A lot of folks never became familiar with the MDA tables. I do have a white paper that talks about this a little bit. There is also a lot on Robert Verschure's website on the MDA tables with install information for the 12.5 folks as well as some basic scripts. I like pointing people there. He's got a lot of useful stuff out there. Note that the monitoring is not on by default. This is something that you have to turn on, but note you do not have to turn all of them on, just the ones that you care about. One problem with the raw data coming out of the MDA tables, Sybase did not provide any analytics that come along with this. You have to write that stuff yourself. So you have to research the MDA tables, pick the information up, identify where the information is coming out of, and do a lot of correlation. And that can be a lot of work as well because when you select from the MDA tables, what you find is that the next time you go to select from it, the data that's in there is different. 2 reasons for that. One is it's planned that way. That way you can continually pull information from the MDA tables, not have to say, bring me the information from that table, which is not already in this table. The other is that the MDA tables are first in, first out queues, and as time goes on, information just pushes itself up off the stack. So trapping this information can be non-trivial. The waits can be transient, and honestly, if somebody calls and said, I've got a problem right now, by the time they get to you and you get to the MDA tables, the problem may be gone. That's one of the reasons it's nice to have a tool and to collect this information full time. So we have the ability to get there. We need to be able to pick this up historically to identify trends. We want to know that the network traffic is increasing over time, that the CPU utilization is increasing over time, and that's what the whole PI does for us. So what ends up happening? Sometimes we end up with a problem query. One of my favorite problems to not have is when we identify that the problem is a stored procedure and there's 5,000 lines of code in the stored procedure. If you were in front of me instead of virtual, I'd ask for a show of hands how many people have to deal with 5,000 lines stored procedures that somebody else wrote maybe 4 or 5 years ago, and you're responsible for the performance. And I usually get a couple of chuckles and a couple of hand waves and a couple people hiding so that nobody points to them and says, well, tell us about it. One of the nice things about these types of tools in the MDA tables is that you can frequently find out which line of the stored procedure was doing that to you. But identifying this in the first place is the big problem that we have to hit. make sure that we identify where the issues are, figure out what the base numbers are, more than how long the query is doing, what is the query doing, where are the wait times for the query, is some other resource bottlenecking while we're waiting for the query, is it being blocked by something? Very useful stuff. Oh, this is a very fuzzy picture. And what this picture is showing us is a particular SQL query up top, which is exposing a lot of wait time. And once again, I'm not trying to push the tool here. What I'm trying to push is a methodology, so I'm not going to worry too much about what the tool does. In real life, by the way, this is a very clear picture and very easy to read. And those different colors tell us about the different types of wait that these individual queries, which are being shown on the left, exhibit. Resolving locking problems is very interesting as well. You've probably all at one point or another been involved in a situation where somebody calls and says, the server's hung, and your response is, no, it's not. I'm in and I'm not doing anything at all. And they say, well, it's not moving for me. I've had this hourglass for 3-4 minutes now. It's not going away. And what you find is that the process is hung. Now, people don't always call and complain about that. Sometimes they call and they tell you about it later. And typically you have to say, well, you need to call me while the problem's there or I can't figure it out. All the information is gone. One of the things that you need to be able to track is how much time your process is being blocked. That information is actually tracked in sys processes. You can figure out how much I/O you're using, how much wait time you've got, how much time you've spent being blocked. That's what DB Artisan does when it shows you wait time and block time. It's just pulling it right out of that system table. Being able to pick this up is very interesting and useful because as you're going, it's nice to be able to say, okay, this process itself, it wasn't being I/O bound, it wasn't CPU bound, it wasn't network bound, just waiting behind another resource because it had something locked. Now, this can open up anything from, oh, gee, this is, by the way, out of actual occurrences. Oh, gee, that process is supposed to be done at 6. You mean it was running at 9? Oh, not supposed to. I'll have to fix that, and we'll fix that for tonight. Sometimes it's a process that wasn't supposed to be running at that time, wasn't supposed to be kicked off. Sometimes it's something that somebody told you was not going to be kicked off. But identifying what's being locked and what's being blocked is very critical. And what we need to be able to do is identify what that locking time is and what that wait time is. Once we've done that, we can say, oh, we're blocked. Now, with a tool, you can frequently go and find out what it was being blocked by. And you can also pick up lock chains. This, by the way, is a picture of lock chains, and it allows you to come down and say, okay, this one was blocking for 3 minutes. Of the 3 minutes it was blocking, this process was blocked for 2 minutes, and there were 2 others lined up behind this one that were each blocked for a minute and a half, respectively. Find out what SQL they were running, what SQL the blocker was running, what else that blocker was running over that time period. Lots of very useful information that you get out of the tool. Very cool stuff. The final one, which is the final example, by the way, not the final problem, here is hardware bottlenecks. And this is a relatively common problem to have. Everything is going after the SAN. Everything is pushing information across the network. CIS is getting lots of traffic. The CPUs are getting bottlenecked. The ability to identify these bottlenecks is the first step. So we go in there and we say, we're at 90% of CPU. Well, what's using all the CPU? Here are the top 5 queries. Let's go and tune these top 5 queries. Oh, now we're at 70% of CPU. Let's look at the queries that are currently bubbling up to the top 5. And go through an iterative process and say, you know what? Now we're back at 60% of CPU. We're in good shape. We're going to relax some. Or we may look at it and say, you know, we've gone from 300 users to 600 users. We expect ourselves to be stuck. Gee, we've only gone from 60% of CPU to 95% of CPU, but 95 is still not healthy. Let's use this to demonstrate that we're consistently hitting 95% of CPU during your busy time. This is also great when people say, you're not network bound. Well, guess what? As I'm looking at this, I'm seeing that 90% of my application is waiting for network time. Well, the network may not be bound, but it's certainly not handling the traffic that we're looking at. How about investigating this for me? Oh, gee, looking at this graph, let me get back to you. Pictures are worth 1,000 words. When you can take this back to your SAN group and say, okay, I know you're saying the SAN is not being stressed, but what I'm saying is I'm not getting enough throughput because I'm spending all my time waiting for I/O, waiting for writes, waiting for reads, doing